Question says, a solid is made up of a cylinder of radius 6 cm and height 12 cm with a hemisphere of the same radius on top. Find total volume and total surface area. Okay, this is a question on the topic volume, total surface area and volume of plane shape and solid shape. This one is a composite shape. Yes, it is combined of different types of shapes. Now, let's try to picture out the information we were given. We are told a solid is made up of a cylinder. How does a cylinder looks? Yes, this is how a cylinder looks. So a solid is made up of a cylinder of radius 6 cm. What is the radius? I think I need my red marker. The radius is a straight line from the center to any point of the circumference. Okay. We are told that the radius is what? 6 cm. Now, the radius is what? 6 cm. And the height is 12 cm. What is the height? From here to here is the height. And we are told is what? 12 cm. And the shape is with a hemisphere. What is a hemisphere? A sphere is just like a circle, but a solid circle, like your football. Okay, your football and the earth. You see a sphere, instead of a circle, it's going to be a solid circle. That's why we call it a solid shape. So this is how your sphere looks like a ball. So when you hear the word hemisphere, it is what? Half of a sphere. Okay, so that means this shape has a cylinder like this with radius 6 cm and height 12 cm with a hemisphere also, half of a sphere. So half of a sphere like this. Remember, it's a composite shape. It has different shape. Half of a sphere of the same radius. That means the radius of this sphere is also 6 cm. From the center is also 6 cm. On top, that means this is on top, just as if it is a cap there. Okay, just like this on top. Can you see the same radius? So just like this, something like this. My drawing is not perfect, it's just a sketch. Now we have to find the total volume and the total surface area. It's very simple. All you have to do now is to start imputing all your formulas, all the formulas you have memorized right from time. Okay, for the areas and volume of plane shapes and solid shapes, what you need is your formula. Total volume. We are going to calculate the total volume of the different types of shapes we have. We are having a cylinder and we are having a hemisphere. We find the volume of the cylinder, find the volume of the hemisphere and add it together. That is going to be our total volume. Okay, so now let's go. The total volume of the cylinder first. What is the total volume of a cylinder? It's going to be the area of the circular part at the top multiplied by the height. You know, the area of a circle is pi r square multiplied by the height. That is the total volume. So it's going to be equal to what? Pi r square, which is the total area of the circular part multiplied by the height, which is h. So what is pi? Let's take pi as 22 out of 7 multiplied by the radius. We were told the radius is 6 cm and its radius raised to the power of 2. That means radius multiplied by radius, then multiplied by the height, which is 12 cm. So here is it. I'm going to multiply all this and divide by 7 to get the area, the volume of the cylinder. Let me punch my calculator. Okay, what I got here is 1357.7, but I'm going to leave it as 358 to make our calculation easy. Your question tells you to leave it in certain significant figures then, but for the purpose of this class, let's leave it in this way to make it easy. So we've just looked for the volume of the cylinder. Remember, we are not asked to look for the volume of the cylinder, we are asked to find the total volume. That means the volume of the cylinder and the volume of the hemisphere. So what is the volume of this hemisphere? The volume. We now go to the hemisphere. Remember, hemisphere is half of a sphere. What is the formula for calculating the volume of a complete sphere? The formula for calculating the volume of a complete sphere is 4/3 pi r cube. Okay, so now that we are not, this one is for the complete sphere, the whole. If we now need half, what do? We multiply it by half, or we divide it by 2, since we are dealing with half. And when you divide this by 2, it's the same thing as what? Multiplied by 1/2. 2 here 1, 2 here 2. That means the formula for calculating the volume of a hemisphere is 2/3 pi r cube, and that's what we are going to use here. 2/3 pi r cube. Now let's substitute 2/3. Pi is 22/7. Radius is 6 centimeter, and it's raised to the power of 3. That is 6 times 6 times 6. We are also going to multiply and divide to get our answers. So I got 452.5. So I'm going to leave my answer as 453 for easy calculation. I'm sure you know volume is in centimeter cube. Forget the fact that I've not put my unit. So our total volume, we are going to add these two together to get our total volume. So let's add it together. 1358 plus 453 gives us 1811 as our total volume. Okay, so our total volume is equal to 1811 centimeter cube. So let me wipe the board so that we go to our total surface area. So in the total surface area, you are calculating the area of the exposed part of that solid. Yes, only the exposed part. For example, here we have 3 different exposed parts. The top of this hemisphere that is exposed, that is 1. Then this cylinder, the side, the curved side, this is 1. The curved side of the cylinder is 2. And which other part can be exposed? The base circle, which is 3. So we are going to calculate the total surface area of these 3 different entities and add them together. First of all, let's look at the total surface area of the sphere. So how do we calculate the total surface area of a sphere, of a normal sphere? The formula we use to calculate the surface area of a sphere is 4 pi r square if it is a complete sphere. But now that it is a hemisphere, half of a sphere, what do? Total surface area, we are going to divide it by 2. Ordinarily, it's supposed to be divided by 2, then it will be what? 2, instead of 4 now, it's now be 2 pi r square. And then we are supposed to add the total surface area of that base circle. Remember, assuming we are looking for just a hemisphere, after we calculate these ones that are exposed, the total surface area now is going to include another circle over here. So you are supposed to add the area of that circle also. But in this case now, that area of that circle is not more exposed over here. You observe, it's not exposed. It has been enclosed inside the cylinder. Therefore, we are not going to add this pi r square h over here because that part of the hemisphere is not exposed. We are only going to use this 2 pi r square for the exposed part. And that's what we do here. 2 pi r squared. 2 multiplied by, what is our pi? 22 out of 7. Our radius is 6 multiplied by 6. We do this to get our total surface area for the exposed part of the hemisphere. The exposed part of the hemisphere. Let's multiply. I got 226.2. So I don't want complications. I will just use 226. And remember, this is supposed to be in centimeter square since it is area. Now the next one we are going to calculate is the second one, the curved part of the cylinder. Remember, it's only the curved part that is exposed right here, and the bottom circle here is the base circle. So the cylinder, let me say curved part. Now to get this curved part, we are going to use the area, the circumference of this circle. If you want to know the height, the length from here around this cylinder, is going to be the circumference of this circle, okay? Because that circle moves up to this place. Therefore, the circumference is going to be the length. Remember, this cylinder, if you are able to unwrap it, it's going to form a rectangle for you. Yes. For example, you can see this book. I can form it to get a cylinder. And then, when I unfold it, it's going to form a rectangle. So, we are looking for the area of this rectangle. Remember, area of rectangle is length times height, or length times breadth, whichever way. So, if this is folded this way, what is going to be the circumference of this circle that is being formed? The circumference of the circle is going to be the length. Okay, can you see it? It's going to be the length of the rectangle, while the height of the circle is going to be the height of the rectangle. So we are going to do the circumference multiplied by the height, which is the same thing as the length multiplied by the height. If it seems confusing, just memorize the formula. So we are going to do this, the circumference of the circle, which is 2 pi r, okay, multiplied by, the height. So 2 pi r, 2 multiplied by pi is 22 over 7. And r, our radius is 6, multiplied by our height is 12. The same thing we multiply to get the total surface area of the curved part of our cylinder. And what I got here is 452.5. So I'm going to leave it as 453 centimeters square for ease of our calculation. Now the final one is going to be our base area, which is pi r square, the base circle of the cylinder. Pi r square, yes. Remember, we have 3 different surface areas. And our pi r square is 22 out of 7 multiplied by, what is our r, is 6. That is 6 times 6. And when we multiply this, what do we get? Let me check. I got 113.14. I'm going to leave it as 113 centimeters square. So we are going to add these 3 different surface areas. Add these 3 different surface areas to get our total surface area. So 113 plus 453 plus 226, and we get 792 as our total surface area. I hope you have learned something. See you in our next class. Bye.